We'll start off with some definitions as we get into our new unit on vectors. A quantity which is just specified by its magnitude, that means its length or its size, that's called a scalar. Examples include distance. If I tell you, okay, I'm 5 kilometers away. Ooh, this would be a fun game. Bonus marks. I'm gonna go 5 kilometers away. Bonus marks to the first student that finds me. Right? Because you don't know which direction I went 5 kilometers away. Right? There I am in the hot air balloon watching you guys run around, and you don't realize I went 5 kilometers up. Right? Or I could just dig a very deep hole. That might be more work. But if you just have 5 kilometers, it doesn't have a direction. In order for something to be a vector, it needs a direction and a magnitude. So if it wouldn't be nearly as much fun if I said, I'm going 5 kilometers north, bonus marks to the first student that finds me, well, you would all be heading in the right direction right away. So the way we differentiate that in our words, instead of distance, we talk about displacement. Displacement is how far you are away in a certain direction. And instead of speed, we talk about velocity, right? I'm going 100 kilometers an hour, that's a speed. I'm going 100 kilometers an hour north, that's a velocity. So what I'm going to get you to do is we've got a bunch of situations here. And I want you to think, does it have a direction and a magnitude, or just one, or does it have neither? So classify all of these as either a scalar, a vector, or neither. And I'll put up the answers in a bit. Scalar, scalar, vector, neither. This one has a direction, but no magnitude. So if you just have a direction, it's going to be neither. It's a vector. That's a scalar. That's a scalar. Again, direction only is neither. Scalar. Vector, vector. Vector. There we go. So how do we show a vector? Well, we show a vector with a straight line with an arrowhead. So here we've got a position vector, OP. So it goes from O and it goes to P. And sometimes you'll see in textbooks they'll write the vector with an arrow in the middle of the line. Sometimes you'll see, wow, the arrowhead on the end of the line. And then we'll have to restart the computer. So you could have that vector arrowhead on the end. That might be something that you like to do as well. You'll see in textbooks that vectors are sometimes bolded, but it's sometimes hard to bold things while you're writing notes. And if you do try to bold it while writing notes, you might just get stuck on making it really dark for a really long time and waste a lot of time. So we generally show vectors ourselves by drawing an arrowhead over top. And we can write our vector, the point x, y, as a column vector. So you write numbers, kind of like a matrix, but a little bit different. So you got your x coordinate on top and y coordinate on the bottom. So we've got a vector A is x, y. That's the position vector, and it has the coordinates x, comma, y. All right. So here we have another vector, OA. It goes to 6, 3, so we could write that as the column vector 6 and 3. I talked about writing vectors as lowercase, and so you could write it as a bold number, but we can't write bold, so sometimes you can either underline it, or sometimes you can draw a little arrowhead over top of the letter as well. This has got screwed up. Wrong order. Oh, that's because everything is really in good position right now. All the buttons are off. The pens aren't working. So the magnitude, sometimes called the modulus, also could just be referred to as the length of the vector. You can write that by putting absolute value bars around it. Now this kind of makes sense because technically absolute value bars, although through your mathematical career you've started to learn that that just means, oh, make the number positive. What's the absolute value of -3? +3. What's the absolute value of 5? 5. But the absolute value in its real definition with numbers is asking how far away, it is a distance question, how far away is that number from 0? So if you're at +3, how far are you away from 0? You're 3 away. If you're at -3, how far are you away from 0? 3 units away. And so the absolute value makes it positive because we always talk about distance as a positive value. Now, if you're trying to find the length of the vector 6, 3, you could draw that vector from 0, 0 to 6, 3, and you can make a right-angled triangle and do a² + b² = c².